Hello everyone. Welcome back into From the Question to the Concept. So today's concept is how do we find the area between two parabolas. So this is the setup, the question what we have for the example, the area of the region enclosed by the parabola is given, and this is the question from JEE 2024 as you can see. So you know how to find the area between two curves, and for that we apply the integration technique. But today's video purpose is to find out or rather derive a formula for any general two parabolas area. It means you are provided with two different parabolas or two quadratic equations in such or any axis, and we can use that formula to find out the area between those curves or those parabolas without doing the integration. But to derive the formula, we will use the technique of integration, and it's so satisfactory to notice how this formula is emerging from a wonderful or beautiful mathematical calculation. So let's see, the setup is this one, but for that we take two general parabolas. So let me just adjust my stylus. Okay, so the idea is this: suppose I have this y is equal to let's take the symbol p1. So p1x plus p1x square rather q1x plus r1. This is one first parabola I have, and then the second parabola is, let's say, p2x squared and q2x and r2, and we have to find out the area between them, enclosed between these two curves. So suppose I have one parabola is open up and the other parabola is open down. It depends how the parabola is set up, but the thing is that if there is no intersection point between two parabolas, suppose I want to draw a parabola like this situation and there is no intersection point, they must be given the x bounds. Otherwise, there is no such way to find out the area between them. So I'm assuming that the two parabolas are intersecting, and the intersecting, maybe the both are upside up, open up rather, or both are in such a way that the one of them is upside down open and up one is open up. So for example, suppose I'm taking this kind of situation and I'm calling it, this is upper, this is this one, and this is the second one, like this. And believe me, I'm not going to calculate the intersection point as we have to do here while solving this question. So let's say I have the intersection point of these two as x1 and x2. I mean the x coordinate of the intersection point are x1 and x2 respectively. So of course this point, this line is x1 and this line is x equals to x2. We are interested to find out the area between these two curves. So this area we have to find, roller shaded area we have to determine. Now the idea is this: in order to find the area between these two, what is the integration setup you make? So to find the area, of course you write the x1 to x2, the bounds, and you write there y above as the red one minus the y below as the blue one. Now suppose and that is dx by the way, and now suppose I find out like this what I get actually. So I have to find the difference of these two y's from here and here. So suppose you find the difference there. So because y above minus y below, if you find the difference, you get like this, that you get is p1 minus p2 x squared plus q1 minus q2 x plus r1 minus r2. This is the expression what we have to write it here. But instead of writing this expression at the place of y above minus y below difference, I'm just inventing a new quadratic equation with the difference of these coefficients of the original two quadratic expressions rather, not equations. So what I mean to say, let me just adjust this first. So what I mean to say is this thing I'm writing as a new quadratic as ax squared plus bx plus c, where this a is our p1 minus p2, b is q1 minus q2, and the c is r1 minus r2. Now once I have this one, I have to find out the integration of this thing. So what I'm writing there is x1 comma x2, and that is ax squared plus bx plus c. Let's integrate it. So I get a by 3x cubed, b by 2x squared, and plus cx, and this will be evaluated on the bounds x1 to x2. So far so good. Now what we do, let's see. I'm evaluating it. So what we get it here, a over 3 x2 cubed minus x1 cubed. I'm finding the upper and the lower bound values simultaneously. I'm not putting the x2 first and then subtracting the altogether value at x1. I'm individually substituting the values of x2 and x1 and finding the difference of them. So that is the same thing. b1 by 2, sorry, b by 2 x1 squared, not x1 squared, x2 squared minus x1 squared, and plus c times x2 minus x1. Now from there I can take x2 minus x1 as a common factor. So x2 minus x1 is a common I've taken here, and that is going to be a over 3, and here I have x1 squared plus x2 squared plus x1 x2. Similarly, the second term, what we have is x2 minus x1 left out, and the third term has only constant c. Now the main calculation and main concept starts from here. The idea is that if I ask you what are the values of x1 x2, you could say that this x1 x2 are the x coordinates when we are solving this two equations. It means I have taken the difference of it. It means you pretend that you have just equated them. If you just find the difference of it, it means that you have equated. It means whatever the solution this quadratic equation will provide, which quadratic equation? Ax squared plus bx plus c is equal to 0. Those values are exactly x1 and x2. So this x1 and x2 are the solution ax squared plus bx plus c is equal to 0 has the two roots, that is x1 and x2. It means that I can claim that the sum of roots will be negative b by a, and the proof is not so difficult because you already know what is happening. And the product x1 and x2 is equal to c by a. You can now notice that where I'm going, that when I write this whole expression, what we have, this one, in terms of a and b, now I'm not dependent anymore on finding the values of x1 and x2, because everything in terms of a and b, and you know that the a, b, c are the differences of the coefficients and the constant terms from the original two equations or the curves. So here you already know that x2 minus x1 is what? So let me just write it. You can see that x2 minus x1 the whole squared is what? x1 plus x2 the whole square minus 4x1 x2. And so that is going to be b squared minus 4ac divided by a square. And you know this kind of things we have done in quadratic. So x2 minus x1 mod, and that is going to be square root of d by a. Okay, so now let's calculate this thing. So here I have x1 minus x2 mod root of d by a, and there I think there should be plus there because I have taken this x2 minus x1. So let's substitute this value. So root d by a I'm writing in the front, and this is a by 3, and again this I can write it as x1 plus x2 the whole square minus 2ab, that is minus 2x1 x2, and plus x1 x2, so that will give you minus of x1 x2, and this is plus b by 2, and again I can write x2 plus x1 value, that is going to be minus b by a and plus c. Now let's substitute other values there. So that is going to be a over 3 x1, that is going to be b squared by a squared, and that is c by a, and plus, not plus, minus b squared by 2a and plus c. Now let's calculate this bracket there. You can notice that this is going to be a over 3, and that is b squared minus ac divided by a, and that is going to be plus 2ac minus b squared divided by 2a. Now let's calculate further. So I can take this is a square, by the way, a square is a cancel, so I can take this a common, rather I'm taking the LCM, so I'll give you 6a square in the denominator outside of this bracket, and here this 2 will be multiplied because a in the denominator both, so 2 times b square minus ac, and here 3 will be multiplied, so 3 times 2a minus b squared, and denominator I have nothing because already have taken, so that is going to be root d by 6a squared, and here it will be 2b squared minus 2ac and plus 6a. Why written the ac? So that is going to be ac, by the way, and there will be also ac, also c, so it will be 2ac plus 6ac, and that is going to be minus 3b squared. You notice that all these things I'm calculating is the area, so I don't need the negative quantity. So one thing we have to keep in mind that everything is positive, so I can take the modulus from the starting. I'm not taking from the beginning, but you know what I mean. So you can notice that there the root d by 6a square, and here 2b square minus 3b square is negative b square, and that is going to be 4ac minus b square. Because I'm taking the magnitude of each quantity, I don't know about the a also, whether positive or negative, so that's why we are taking all these things modulus, and you can now notice that the b square minus 4ac or 4ac minus b square will result into the root d again, so they'll give you d, and that is going to be d root d, and then 6a square. So we have actually established a formula to find out the area between two parabolas is given by the discriminant to the power 3 by 2 by 6a square, and you can notice there in the discriminant is the discriminant of the quadratic found by the difference of the two quadratics. So now let us evaluate the area of this two parabolas. So first I write this parabola as y is equal to x squared minus 5x plus 0, and the second parabola I have negative x squared plus 7x plus 0, and we find the difference of these two parabolas to find out the new quadratic and to find out the a and b and c. So that is going to be 2x squared, and that is minus 12x and plus 0. It means the discriminant what I'm finding is just 12 squared, that is 144, because 4ac, the c is 0, that's why that is 0. So the area what we are looking for is going to be d to the power 3 by 2 divided by 6a squared. A value is 2 for the new one, so that is going to be 144 to the power 3 by 2 and 6 into 4, and after that the calculation is easy. One caution we have to keep in mind that whenever I'm finding the difference of these two, so in this you may think that okay, let's divide by 2 and make a simple quadratic. No, The difference, because we are not equating with 0 to do anything, so of course we should not cancel. This is one caution. The second beneficial thing is that we can take the benefit is that this is applicable when we are taking a quadratic and the parabola, sorry, a quadratic and a line also. So for example, I have this question, the area of the region bounded by the curve, and the curve is I have 1/4 of x squared. I can write 0x plus 0. And the second thing I can write y is equal to, that is going to be x plus 2 by 4, which can be further written as 1/4. Let me write in this way. I can write it as y is equal to 0 times x squared plus 1 by 4 of x plus half. And now this curve and this curve I'm finding the difference of, and that is going to be 1/4 x squared and minus 1 by 4 x and minus half. So this way you can think that there may be a temptation to cancel this thing because it's a weird looking fractions we have. So we don't have to do, otherwise the answer will be altered. And why the answer will be altered is also very easy to understand, because when you are finding the difference and we are cancelling out the factor, maybe you are getting the difference of the two, not this quadratic, means maybe you are finding that getting the difference of the two distinct curves and the area you are finding of the two distinct curves. Therefore that 1 by 4, 1 by 4, 1 by 2, so whatever comes the difference at the first hand, we have to keep it throughout the process. So we have to find the area. So what we do there, that is the delta we have to find, that is d, or the d we have to find. So b square minus 4ac, that is negative 1 by 4 the whole square, minus 4ac, that is 4, minus half. Let's calculate it. So that's going to be 1 by 16, and that is going to be 4 cancel plus half. So that is going to be 9 by 16 perhaps, and I have a value is 1 by 4, so of course I will take a square is 1 by 16, and to find out the area will be given by delta to the power 3 by 2, that is 9 by 16 d to the power 3 by 2, and here I have 6 into 1 by 16. So that is going to be, first I take the root and then cube, so 3 by 4, 3 by 4, 3 by 4, and in denominator I have 6, and again this 16 will go on the top. Of course this 4, 16 will get cancelled, and I have now 3, 3, 3, and that is 6 into 4, 3 to 6, so I'm getting 9 by 8 perhaps. I have done a mistake, I don't know. 9 by 8, yes, is already in the option. So in this way this formula is useful. I'm not recommending to memorize the formula, but I'm saying just practice few questions on in this way. The formula will be automatically committed to your memory. Let me take one more example to show you what is the benefit of it. So suppose you have one question like this, that there is a parabola which is open rightward, and let's say this parabola is y square is equal to, let's say, 4x, and there's another parabola, let's say it's like this, and I don't know where it is. So let's say this is y square is equal to 4 times 3 minus x. Because of the negative x, it is actually oriented open left. Now we have to find out the area between this. So again we can do this same thing. How? Now this time I'm going to write this as a quadratic of y, and how do we write? So x for that one, for this one I'm writing in red, so that is x is equal to y square by 4, and for this green one we can write in green, so that is going to be, first I write this thing in a simple way, so y square by 4 and 3 minus x, so x is equal to 3 minus y squared by 4. So if you want to find the difference, again you write it in more consistent way. So minus y squared by 4 and plus 0y plus 3, and there's also 0y plus 0. And you find the difference, that will give you 1 by 4 plus 1 by 4, 2 by 4, so 1 by 2y squared. And this has no such thing, there will be 0 y and there is minus 3. It's a new quadratic, and again you can find out the area between these two curves. So this is the benefit of this thing. I hope you learn any new things and you will apply this in your problem practice. See you in the next video of From the Question to the Concept. Stay math active.